So in this video, we're going to talk about describing the shape of graphs. Now, describing the shape can tell us a lot, especially about the trend of the data and how we expect it to increase or decrease, getting an idea of what's expected for our data. So the first piece we'll look at is shape. So with shape, and these are actually going to come from unimodal graphs. So a word you're going to be seeing, or kind of a form of the word, is the idea of mode, which is the most frequent data value. So it's the data value that occurs the most. So with that, in terms of these graphs, and I'm going to be graphing these as histograms. With the histograms, this would represent the peak of the graph. It's kind of where the highest point comes in. That bin that would have the highest point would be, or the highest frequency, that would be our mode. So these graphs I'm going to show here with symmetric, skewed left, skewed right, these are all going to be unimodal because that's typically what we'll be dealing with in this class, which would be the idea of having just a single peak for our data. So symmetric unimodal, what that would look like is, so it would have symmetry, the idea that if you fold it in half, it should roughly be the same on both sides. So something like this. It'll rarely be perfectly symmetric. Something like this, that it's close to how it kind of decreases out from the peak with that highest frequency, is similar on both sides. Some other words you'll see for this is this general trend that we're seeing here of going up to a single peak and then decreasing out. Instead of symmetric, you might see bell-shaped sometimes. And another way that we'll refer to this curve later in the term is a normal curve. All of those represent the same idea here. Skewed left, what that will look like is we might have this kind of tail of data over here, and then the bulk of the data over on this right-hand side. So if we kind of look at the general trend here, it's like we have some of that bell-shaped curve that we're seeing, but there ends up being this tail to the left-hand side, and that would be skewed left. Then skewed right is a similar idea. We'd have the bulk of our data on the left-hand side, but then we'd have this kind of tail on the right-hand side. So it's very common to mix these up, skewed left and skewed right, especially when you hear skewed left, you feel like it's skewing the data to the left, but it's actually the tail that we're interested in. It's these extreme values out here that are important for our data. And we'll talk about this again when we start talking about mean and median and how those change based on having these kind of extreme values in the tails. So if you're ever confused if it's skewed left or skewed right, what I always ask myself is, where is the tail? That's what we're looking at. Where are the extreme values coming through? So this is typically the terminology that we'll be using when we're describing the shape of data, because usually it'll be unimodal with a single peak, and then we just need to decide, is it symmetric, skewed left, or skewed right? Now there are other forms, so what we just saw up above there, those are all examples of unimodal, but we could have no mode, and this is also called uniform data. And it's where the data behaves in a uniform way, in that if we have a histogram, it's that the frequencies would be very similar. It might not be perfectly flat, but it should look like a somewhat flat graph. Bimodal should mean two peaks for our data. So we might see something kind of symmetric, and then what we'll see is in another spot on the graph, another peak. So if I kind of just map the trend here, we'd increase up, decrease down, and then increase up again, decrease out. That's a bimodal graph. And then multimodal just means more than two peaks. So we'd see some peak of data. And something that might happen here is the peaks don't have to be the same height. What you want to think of, or rather how I think of it, I think of a roller coaster, in that this has the trend of you're going up, you hit the top, and then it goes down, and then it turns, and then you go up, and then down. So with that, this kind of increasing up and out of it, That's what's making modes. Because what you might see sometimes with graphs is maybe we'd see something that's pretty much perfectly symmetric, but maybe you have something like that. Now that trend right there in a very small scale, that's just one bin that dipped down. Really, in terms of trend, we could just skip over that, and overall it is symmetric, just something strange happened in that bin. With bimodal and multimodal, to make a mode, it's really this like roller coaster of increase up to the peak of it and decrease out. Having that trend together is what makes a mode. Having just a single bin that's a little smaller than the others doesn't suddenly make this its own mode. It would still be overall unimodal. So that's how you can see different shapes. And with uniform data just tends to not be that interesting. I mean, it's interesting that it's uniform, but in terms of like expected outcome, it could be anywhere. Like everything is likely. So in terms of describing the data in center and spread, not that much to say about it. Bimodal and multimodal we want to be careful of, because that is showing subpopulations. Having data with multiple modes means that there's probably a lurking variable in there, something that's actually separating our data so that we can see these different trends. So for example, let's say I use that multimodal graph up above there. An example for how that could come through is, say I ask you to go to a grocery store and collect the fiber content of various breads. If you do that, you might see something like this coming through, because what we would have are these subpopulations for types of bread. Like you probably have this subpopulation for white bread, which tends to not have very much fiber at all, but within that group, you'd have trends for it. Like if this was the white bread group, it'd be, okay, very little would have absolutely no fiber, but then some would have a little, and then some, like compared to others, overall it's going to be lower, but within its own little realm, it would have trends. And then we would have like wheat bread would have its own trends. And then like multigrain, which is the higher fiber breads, would have their own trends. So what would happen is you'd have these three groups coming through just based on these kind of subpopulations. And we wouldn't really want to look, I mean, seeing that data all together is important and seeing how they work. But in terms of moving on to describing center and spread and unusual features, we'd want to separate them. We would want to look at behaviors for just white bread, just wheat bread, just multigrain, instead of all of them together at once. So we want to be careful of subpopulations, because it means we should actually probably separate up our data by whatever this lurking variable is. So we want to be careful of subpopulations. We also want to be careful with outliers. In fact, when we get to describing our data, we'll usually want to describe any outliers that we can find there. These will typically come up with skewed data. They rarely happen with symmetric data, but it is this idea of having this trend on one side of your graph, and then suddenly you have something way out there. It's important to recognize outliers because there are these extreme values. So what it could show is seeing something unlikely happen, which is interesting, and we want to make note of it. But in terms of trends, we actually don't want to take into account outliers too much, because really the trends are happening over here with the bulk of the data. Another thing that can be happening with outliers is it could just be an error from the researcher, like their input. Maybe they just typed in something wrong. They'd want to double check that. So we want to be careful of outliers for these reasons. So in terms of what we'll be doing in our class, we'll look out for outliers, we'll look out for subpopulations, and we'll talk more about outliers and how to actually calculate whether or not something's an outlier. And then from there, we really want to focus on unimodal graphs and describing their shape as symmetric, skewed left, and skew right. In fact, when we get to describing center and spread, there's going to be this separation of specifically what we do for symmetric data and what we do for skewed data, because with skewed data, values are getting skewed in there as well, and we want to be careful of that.